4.8, factoring by grouping. When we factor by grouping, some of these are going to be factored for us partially, some of them will not be. We will have 4 terms, and we will we will group the first 2 terms and group the last 2 terms and factor out whatever our greatest common factor is from each set of parentheses. And then from there, our 2 sets of parentheses should be the same, and whatever we have as that we factored out, we're going to make another set of parentheses with and rewrite one of the same parentheses that occurred. So if we look at example A, we have 5 times x plus y plus w times x plus y. So we realize that these 2 parentheses are the same, so we are going to rewrite one of them and then make another set with the 5 and the positive w. So it's going to be 5 plus w. And that's it. If they were not factored for us, then we would have to factor out the greatest common factor to get where we're starting off here. So if we look at example B, we have m times m plus 4n minus m plus 4n. So this minus out front of the m plus 4n in this second set of parentheses is like saying minus 1 times m plus 4n. So we realize that these 2 sets of parentheses are the same. We can rewrite one of them, so m plus 4n. And then we're going to make another set with the m and the negative 1, so it's going to be m minus 1. If we look at example 2, we have 5 times a minus 3 minus 2a times 3 minus a. So we want to put this in the same order. Our parentheses should be in the same order. So a comes before our constant. With the first, we're going to do the same thing with the second. So we're going to keep that first one, 5 times a minus 3. Then we're going to have negative 2a times negative a plus 3. You'll realize that these 2 sets of parentheses have opposite signs for each other. So in order to get that a, that second a, that negative a, positive a, we can divide it by a negative 1. When we divide that positive 3 by a negative 1, it's also going to turn it into a negative 3, just like the first set of parentheses. So we're going to divide this by a negative 1. When we do that, we're going to multiply the term on the outside of the parentheses, that negative 2a, by negative 1. So this is going to turn that a to be positive and that 3 to be negative. So we're going to have 5 times a minus 3 plus 2a times a minus 3. Now our 2 sets of parentheses are the same, so we can rewrite one of them to be a minus 3 and then make another set with the 5 and the 2a. If you would like to move the 2a forward, you can. Just make sure that if it's positive, that you can do that. That's fine. If it was negative, I would keep it to the second term. For B, we have 2ab minus 6ac plus 3b minus 9c. So we're going to group the first 2 terms, and then we're going to group the last 2 terms. So we're going to put parentheses around the first 2, then parentheses around the last 2. With the first 2, the 2ab minus 6ac, our greatest common factor is 2a, so we're going to factor out a 2a. For the second set of parentheses, the 3b minus 9c, our greatest common factor there is just a 3. So we're going to factor out a 2a from the first set of parentheses. We're going to have b minus 3c left. And then if we factored the 3 out, it would be a positive 3, so it's going to be plus 3 times what would be left over, b minus 3c. Our 2 sets of parentheses are the same, so we're going to rewrite one. So that's going to be b minus 3c, and then we're going to make another set out of the 2a and the positive 3. So this is going to give us b minus 3c times 2a plus 3. Our next example, we have 4p squared minus 4pq plus 8p minus 8q. So we are going to put parentheses on the first 2 terms, and then parentheses on the last 2 terms. The greatest common factor between the 4p squared minus 4pq is 4p, so we're going to factor out a 4p from there. And the greatest common factor with the 8p minus 8q is an 8, so we'll factor out a positive 8 from that. So this is going to leave us with 4p times what's left over, p minus q, and then a positive 8 factored out of the second set, and that's going to leave us with a p minus q. From here, our two sets of parentheses are the same. So we have p minus q as 1, and then 4p plus 8 as another. Now, you'll realize that that 4p plus 8, they both share a common factor of 4. So this one we're going to factor out that 4, and this is going to give us 4 times what's left over, p plus 2, and then we're going to rewrite the p minus q as well. So totally factored is 4 times p plus 2 times p minus q. If we look at some more examples for 1, we have a squared minus 2a plus 3a minus 6. We're going to factor by grouping here because we have 4 terms. So we're going to do a squared minus 2a in parentheses and then the 3a minus 6 in parentheses. Our greatest common factor with the a squared and the 2a is an a. The greatest common factor between the 3a and the negative 6 is 3. So we're going to factor out the a from the first set. We'll be left with a times a minus 2, and then the 3 times a minus 2. Those two sets of parentheses are the same, so we're going to form one with the a and the positive 3, and then we're going to rewrite the second set of the two parentheses that are the same. That doesn't look good. Let's try this one. There we go. That looks better. All right. So if we look at our next example, we have pq plus p minus 4q minus 4. So we put two sets of parentheses here, one around the first two, one around the last two. We're going to factor out a p from the first, and we're factoring out a negative 4 from the second. This is going to leave us with p times q plus 1 and negative 4 times q plus 1. Our two sets of parentheses are the same, so we're going to rewrite this as p minus 4 times q plus 1. For 3, we have 2r squared minus 6r minus 5r plus 15. So two sets of parentheses, one around the first two, one around the last two. We're going to divide out the greatest common factor between the 2r squared minus 6r, and that's going to be 2r. The greatest common factor between the negative 5r and the positive 15 is a negative 5. We want to make sure that first term has the same sign on both sets of parentheses, which is why the negative 5r, we're taking the negative out of that to make it a positive, just like the 2r squared. We want to make sure that with all of our parentheses, the first term in the parentheses is always positive. So this is going to give us 2r times r minus 3 and negative 5 times r minus 3. This is also factoring out further to be 2r minus 5 and r minus 3. For example 4, we have x plus 2xy minus x minus 2y. So parentheses around the first two, parentheses around the last two. Your greatest common factor between the x squared plus 2xy is x. Your greatest common factor between the negative x minus 2y is negative 1. So this is going to leave us with x times x plus 2y and negative 1 times x plus 2y. So our two sets of parentheses are the same. So make one with the x minus 1, and then another is the x plus 2y. For 5, we have u squared plus uv minus v squared. So two parentheses, factor out the u from the first, factor out the negative v from the second. This is going to leave us with u times u plus v minus v times u plus v. Two parentheses are the same, so this is going to give us u minus v times u plus v. For 6, we have h squared minus 2h plus 4 minus 2h. So this first set, we're going to factor out an h. The second set, we're going to factor out a 2. So this is going to give us h times h minus 2, and then a positive 2 times 2 minus h. We're going to rewrite this to where the h comes first in the second set of parentheses. This is h times h minus 2, and then 2 times negative h plus 2. We have opposite signs in these parentheses, so this is going to be turning into a negative, and same thing with that 2 that's out front. So this is going to leave us with h minus 2 times h minus 2. And again, you can rewrite this as h minus 2 squared. If we look at 7, we have x squared minus 4x minus 4 plus x. So I'm going to start by rewriting this as x squared minus 4x plus x minus 4. So that way my terms are in the correct order. Parentheses are on the first two, parentheses are on the last two. We're factoring out an x from the first, we're factoring out a positive 1 from the second. So it's going to be x times x minus 4 plus 1 times x minus 4. This is then going to give us x plus 1 times x minus 4. For 8, we have mn minus m squared minus mn minus n squared. So again, I'm going to put parentheses around the first two, put parentheses around the last two, factor in an m from the first, factoring out an n from the second. So this is going to give me m times n minus m plus n times negative m minus n. So if I rearrange my terms in both sets of parentheses to be where my n is first, I'm going to do m times n minus m plus n times negative n minus m. If I turn that negative m into positive n, just like my first one, I'm going to change the sign on all of my terms, but this is not going to give me the same set of parentheses for each. Oops. So because it's not the same, it's not factorable, so this is prime. For 9, we have 2r squared minus 2rs plus rs minus 2r. So we are going to first realize that we have a greatest common factor here. Every term has an r, so we can factor out the r first. So this is going to be r times 2r minus 2s plus s minus 2r. So we factor by grouping now. We're going to put two sets of parentheses. The 2r minus 2s, we're going to factor out a 2. The s minus 2r, we're going to factor out a 1. So this is going to be r times 2 times r minus s plus 1 times s minus 2r. We cannot factor any further after we factor out that r. So this is all going to go away. We're not going to do this, and our answer is just going to be the r times 2r minus 2s plus s minus 2r.